All right, today, ladies and gentlemen, we're going to be talking about graphing. We're going to graph square root and cube root functions, square roots on this page. So we're going to talk about what the original square root graph looks like, and then we're going to twist it and turn it and shift it all around different places and see what how those equations affect that graph. Okay, so let's start with our base, or our parent function, y equals the square root of x. Now this is the inverse. Square rooting and squaring are inverses. Remember, a parabola goes through 1, 1, and 2, 4, and 3, 9. So it looks about like that. We're doing the inverse of that. An inverse function is the reflection of this graph over the line y equals x. So if you take this graph and reflect it, you get this graph. However, just the symbol square root of x is only the positive square root of x. If you include the bottom part of that sideways parabola, then you don't have a function anymore because it fails the vertical line test. So realize, unless there's a plus or minus in front of your square root, we're only taking the positive square root of the number. So with that in mind, a general basic square root graph goes from 0, 0 to 1, 1, because the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and this is our parent function, the square root of x. Okay, it has a domain of x is greater than or equal to 0. We can plug anything 0 and up into the square root and not have a problem. The problem is when it goes negative, which is why our graph does not move to the left. And our range is going to be the same, but for y. Y is greater than or equal to 0. All right, because it starts at the axis and it never stops moving up. It's kind of like a natural log graph or a regular log graph. It keeps growing, but growing very slowly. It will eventually reach any height you need it to, but it just doesn't get there very quickly. So this is the graph that we're going to start with. 4 times the square root of x minus 5. This graph takes that original graph and it does a couple things to it. Remember, you can always graph by plotting points. But once we start to learn more about translations, we'll see that this thing goes down 5 and it has a vertical stretch times 4, which just makes it 4 times taller. So let's plot a couple points and we'll see how those translations happen to our original yellow picture. So you want to plug in points that you can take the square root of, right? If I plug in 0, square root of 0 is 0, 4 times 0 is 0 minus 5. So 0, negative 5 is 1 point on my graph. I can plug in 1 and I get the square root of 1 is 1 times 4 is 4 minus 5 is negative 1. Plug in 4. I don't want to plug in 2 and 3 because when I do, I get irrational values, never-ending decimals that aren't nice on a graph. I could plot them, just round the decimal and plot, but I'm just going to choose good values. So I'm going to plug in 4. Square root of 4 is 2. 4 times 2 is 8. 8 minus 5 is 3. So that was 2, excuse me, that was 4, 3. And then I'm going to plug in 9, again, because I can square root 9. Square root of 9 is 3 times 4 is 12 minus 5 is 7. So I get 9, 5, 6, 7. So that's one way. You can always go back to point plotting. Choose some points and connect the dots. You have a good idea of what square root graphs look like, so you'll know that you're on the right track. But this thing got a vertical stretch times 4, which made it taller. And then it got moved down. Always shift last. So if you're going to take that original yellow graph, stretch it vertically, make it taller, then move it down. Sometimes it doesn't matter if you shift last, but it's safe to do it that way because sometimes it does. Okay, so a little more quickly, let's do these bottom ones. I'm going to actually pause, fill in some XY values, and skip to these graphs for the sake of time. Okay, so I've plugged in some values of x into this next equation. I chose 1, 2, 5, and 10 because the first thing I do is subtract 1 from those, and 0, 1, 4, and 9 are my perfect squares that I can evaluate the square roots of. Then I multiplied each value by -2, so let's see what we get. 1, 0, and 2, -2, 5, -4, and 10, -6. So our original graph, remember, we're just taking that yellow graph that I drew first up top here, and I'm shifting it and translating it in certain ways. So what happened to it? Well, this negative sign was a vertical flip. All right, flip is not a technical word, but you call it a reflection. Flip's just easier. So that made it flip upside down and live below the axis. And then this -1 was a right shift of 1. Horizontal shifts go the opposite of the sign. So if you have x -1, then it has to live at +1 or bigger. So our domain here is all x's that are allowed to be plugged in, which is x is greater than or equal to 1. Our range is all the y's that come from those, which is y is less than or equal to 0. Okay, domain, analytically, think about the square root. What cannot be under a square root? Negative numbers. So if under your square root you have x -1, your x value has to be at least 1 in order to make x -1 0 or bigger. Graphically, your original yellow graph got shifted 1 to the right, which makes my domain greater than or equal to 1, not greater than or equal to 0. There's kind of two approaches to that domain, but either way you should be able to look at that equation or that graph and know what the domain is. All right, so this last one I want to approach strictly with my translations. I don't want to plug in points on this one. I want to think of it in terms of what do the 4 and 2 and negative sign do to this graph. So let's start with this. When you have x with something in front of it, whether that's just a negative sign or a coefficient, you need to get that coefficient off of the x to interpret what your translations are going to be. So I need to think of this as negative parentheses x -2. You'll see it on our graph in just a minute. If you go by +2 and think, all right, I just heard that if it's +2, I need to move the opposite. I need to move left 2. That's going to give you a problem because of that negative sign in front of the x. Get the negative sign out, and now we see that it's x -2, which means it's going to go 2 to the right. Okay, so let's see what these numbers do. This 4 is going to make the whole thing go up 4. This 2 is going to be a vertical stretch times 2. The negative sign inside is going to be a horizontal flip. That's that negative sign with the x that I factored out. It's still with the x. That's going to be a horizontal flip. It's going to make it go side to side. And then my 2 that's now negative after I factored out the negative sign means it's going to go 2 to the right. Okay, so let's start with my original graph. My original graph we talked about goes through 1, 1, 4, 2, 9, 3, like that. And now these changes have happened to it. It has a vertical stretch, which means that when I was at a height of 1, now I'm at a height of 2. I was at a height of 2, now I'm at a height of 4. When I was at 3, now I'm at 6. So the vertical stretch takes that original graph and does that to it, stretches it out twice. So there's the vertical stretch times 2. Gotcha. I'm going to shift last. So next I'm going to do my horizontal flip. Now that horizontal flip takes every point that was on the right and moves it over to the left. So 1, 2 is now negative 1, 2. This one comes over to here, and this one comes up to here. And every point needs to get moved to the left side of the graph instead. Now I go up 4 and right 2. So I'm actually just going to take that same picture and clone that baby. It was right here. It's going to go up 4 and right 2. So using the very starting point as my base, 1, 2, 3, 4, right 2, and there we go. So now I'll put this one in a better color. My final graph looks like that. Okay, so if you graph one, especially by the translations, it's always a good idea to plug in some points and see that you're on the right track. So like if I plug in, I don't know, let's plug in -2. If I plug in x equals -2, I get 4 plus 2 times the square root of -2 plus 2. Okay, so -2, that's 2, plus 2 is 4, square root is 2, times 2 is 4, plus 4 is 8. So -2, 8. And my graph goes through -2, 8. And you don't have to plug in a whole lot of points to tell if your graph's in the right spot. So that final yellow graph is the original graph with those 4 translations happening to it. Now, once again, you don't want to graph this based on translations and not check. You can plug in points for any graph at any time. Choose some x's. All right, so now, quickly, let's talk about some cubes, some cube roots. Y equals the cube root of x. It's a little different because you can put any x value in. You can cube root anything because cubes can be negative. The range is also all real numbers. That r with the 2 stems, that's all real numbers. Cube root of 1 is 1 because 1 to the third is 1. Cube root of 0 is 0. The cube root of -1 is -1, right? Because what do you need to raise to the third power to get -1? -1 to the third is -1. And then we can also, our next good value is probably 8. Cube root of 8 is 2. Cube root of -8 is -2. All right? So connecting those dots, here's a cube root parent function. I probably should have gotten a little steeper there in the middle. It kind of flattens out and then goes back up, but get the idea. Now, those same translations that we talked about earlier can be applied to this graph. Let's take our cube root graph and make a copy of it. Here's cube root. Now this one has a +4 on it, which just means 4 up. So I'm going to take that function, slide it up 4 spots. It's going to live about right there. So there's the cube root of x plus 4. That +4 is a vertical shift up 4. Let's make another copy. Let's see that. Let me list that. The domain is still all reals because I can still plug in anything. The range is still all reals. And that 4 made me go up 4. Think about this one. Think about whether this one's going to go left or right before I say x plus 1 underneath the radical. Remember what happens to x's. They go the opposite way. The 1 is going to make it go left 1. And other than that, it's just the same. All reals domain, all reals range. And originally it was about right here. And I went left 1. So I'm going to take that middle point and move it over 1. And there you go. All right, you can always check values. Plug in 0, what do you get? The cube root of 1, which is 1, which is why my graph goes through 0, 1. We're really relying on the good points, the points that give me whole number values to do our checking. All right, one more. -2, cube root x minus 4. All right, so what happens to this one? It's -2 does 2 things. The 2 makes it a vertical stretch. The negative is a vertical flip. And the 4 on the inside makes it go 4. It says -4, go the opposite, 4 right. All right, so let's take our original the original graph of cube root. Remember, we just drew it a minute ago. 8, 8, 2, negative 8, negative 2. So there's the original. We need a vertical stretch, a vertical flip, and 4 to the right. I want to shift it last. Let's do the vertical stretch first. 1 becomes 2, 2 becomes 4, 0 stays at 0, negative 1, negative 2, negative, that should be at 8, not 9. And so here it is under a vertical stretch times 2. Then a vertical flip takes all points that were above the axis and moves them below. Takes points that were below and moves them above. So now we are here. And then finally, 4 to the right. I'm going to clone that. I think. I'm not sure if I can get the right one, so I'll just move it dot at a time. All points go 4 to the right. So this point right here, 1, 2, 3, 4, over to 5. This one was at 0, now it's at 4. This one was at negative 1, now it's at 3. Negative 8, 1, 2, 3, 4. My point over on the right is actually off the graph now. Here we go. So that green one is my final answer. And we did that one according to the translations, not point plotting. But again, plot some points and make sure you get the right answer. You know, what could you plug in? You could plug in 4. When you plug in 4, what do you get? 4 minus 4 is 0. Cube root of 0 is 0. Negative 2 is still 0, which tells me that my point right here is in the right place. And if that one's in the right place, then they probably all are. If that one's wrong, if you shifted the wrong way, then plugging in 4 would give you something that's not on your graph. So always check them to make sure that you've gone the right way. All right, so that's going to wrap it up. These are our square and cube root graphs. We'll keep, as we go, learning about translations and pick good points and connect the dots, the theme of graphing. All right, so I hope you've enjoyed it. Young out.